Guys, let's continue. So today we'll start properties of Laplace transform. So we'll be using this if Laplace of ft is equal to fs. So this is the general that we will be using. So our first property is change of scale. According to this property, your Laplace of f of at is 1 by a f of s by a. So if Laplace of ft is fs, then Laplace of f of at is this. So let's take an example. For example, if you have Laplace of sine t, as you know, this is 1 upon s square plus 1. So let's say, what would Laplace of sine 6t be? So according to this, here a is 6. So 1 by 6. F of s by a means you replace s with s by a in the formula that you have. So this will become 1 upon s by 6 square plus 1. Now we already know the formula of Laplace of sine at. So technically you do not need this here, but I'm just showing you an example of the change of scale property. So this becomes 1 by 6, 1 by s square plus 36 into 6. So this gets cancelled and you get 1 upon s square plus 36. So this is the first property. Let's look at the second property. This is an important one. It is called first shifting theorem. So according to the first shifting theorem, if your Laplace of ft is fs, then Laplace of e raised to at multiplied by ft is f of s minus a, which means you just have to replace s with s minus a in the answer. Or if you have e of e raised to minus at multiplied by ft, then the answer becomes f of s plus a. Let's take an example. For example, you have Laplace of e raised to minus 2t multiplied by sine 4t. So we can find out the Laplace of sine 4t first. This will be 4 upon s square plus 4 square, which means 4 upon s square plus 16. So Laplace of e raised to minus 2t multiplied by sine 4t becomes, you replace s with s plus 2 as you have minus a over here. So it becomes s plus 2 whole square plus 16. This is the answer. Your next property is multiplication by t. So if you have Laplace of ft is equal to fs, then Laplace of t raised to n multiplied by ft is minus 1 raised to n dn divided by dsn of fs. I'll show you this with an example. For example, you have Laplace of sine t. This is 1 upon s square plus 1. So what is Laplace of t sine t? So here your n is 1 because there's only one t. So n is 1. So you get minus 1 raised to 1 d by ds of fs, which is this. D by ds of 1 upon s square plus 1. So this becomes minus, and when you differentiate this once, you'll get minus 1 upon s square plus 1 whole square into 2s. So your answer becomes 2s divided by s square plus 1 whole square. Now if you had, suppose you had Laplace of t square sine t, then it would be minus 1 square d2 by ds2 1 upon s square plus 1, which means you need to differentiate this twice. Then you will get your answer. So guys, make sure you go through the examples that are in my notes. Now let's do one more question so I can tell you in what order you should go with. So for example, you have Laplace of t square e raised to t sine 4t. Now here you need both properties, t raised to n and e raised to t. So since you need both properties, which order should you use them in? So remember guys, when you have these type of questions, you should always use this property in the last, because you just have to replace s with s minus 1. If you do this first, then your differentiation will become difficult because you have multiplication with t. So let's write L of sine 4t. This is 4 upon s square plus 16. Now let's find Laplace of t square multiplied by sine 4t. This becomes minus 1 square d2 by ds2 4 upon s square plus 16. So let's differentiate this once first. Minus 1 square becomes 1. So this is d by ds of 4 upon s square plus 16. Basically, you just need to differentiate this twice. So you got d by ds of 4 minus 1 upon s square plus 16 whole square into 2s. So this becomes d by ds of minus 8s by s square plus 16 whole square. So I'm going to write this as minus 8 d by ds of s divided by s square plus 16 whole square. Now I'll just write the quotient rule for those of you who don't know. So if you have a function u upon v, then differentiation of this u upon v is v u dash minus u v dash divided by v square. So what you're gonna do over here is, in this one, this means you'll write the denominator as it is, s square plus 16 whole square, multiplied by differentiation of u, which is 1, minus, you'll write s, and then differentiation of s square plus 16 whole square, which is 2 s square plus 16 into 2s. Divided by denominator whole square, which is s square plus 16 whole square becomes raised to power 4. So now let's simplify this a little. You get minus 8. I'm going to take out 1 s square plus 16 as common. S square plus 16. You're left with s square plus 16 minus 4s square divided by s square plus 16 whole raised to 4. So you can cancel 1 and this is left as cube. So your answer becomes 16 minus 4s minus 3s square divided by s square plus 16 whole cube. Multiplied by minus 8. So finally we can write this as 8 times 3s square minus 16 divided by s square plus 16 whole cube. So this is your Laplace of t square sine 4t. But what do we need? We need Laplace of t square sine 4t multiplied by e raised to t. Laplace of t square sine 4t multiplied by e raised to t. So using the shifting property, what we need to do, we need to replace s with s minus 1. So your answer will become 8, 3s minus 1 whole square minus 16 divided by s minus 1 whole square plus 16 whole cube. This is your answer. I have taken this example to show you that you need to do this thing in the extreme last. Otherwise, your differentiation or whatever other methods you need to do, they will become more complicated. So you're going to do this in the extreme end. So guys, please go through the notes that I have uploaded. They have a lot of examples, and I'll be covering the other properties in the next video. So if you guys have any doubts, leave them in the comment section. I'll answer. Thank you.